I just start the program formally now. I hope all the participants might have come now. And just to start with the program, my name is Pankaj Gupta. I am representing Building Materials and Technology Promotion Council, which is an autonomous body under Ministry of Housing and Urban Affairs, Government of India. And this is the 13th program in series, this NAVARITIH program. As all of you know, must be knowing that this program is specially designed for the professionals, and that's why we have kept the timings in the evening from 5:30 to 8:30, and during the weekend from 2 to 5. And this is going to be a 8 days program, and there will be 2 sessions on different technologies every day. And starting with today, we have the, let me just tell you the brief about the program which is going to be held. As I told you, there will be 2 sessions every day, and today's session will be on the emerging construction systems, introduction and opportunities and challenges. Sorry for the second session for the today's program, which was to be given by Professor P.S.N. Rao on the emerging construction systems introduction, as he is not available. But the whole introduction about the new technologies and their opportunities and challenges and everything in detail will be done by our Executive Director, Dr. Shailesh Agrawal. So first of all, we will be taking up his lecture, and tomorrow, being a Saturday, the program will start at 2 p.m. and will be for 3 hours. 2 sessions will be there. One will be on the formwork system, which will be taken up by Dr. K.M. Soni. He is a retired ADG from CPWD. And the second session will be taken up by Professor Meher Prasad, who is from IIT Madras. And the session will be on GFRG panel systems. On Sunday, which is the third day, again, the session will start at 2 p.m. and up to 5 p.m. it will go, and we will have 2 sessions on that day. One will be 3D technology, concrete printing technology, which will be taken up by Dr. Biranchi Panda from IIT Guwahati, and the stay-in-place formwork system will be taken up by Shri Amit Pal from Adani Group. We have the faculty from the industry also, apart from our regular academic institutions. We have faculty from industry also. And the day 4, which will be Monday, it will again start at 5:30 in the evening, and we will have a presentation by Mr. Mutha Zagan, L&T, and he will be talking about the formwork system and its implementation and the case studies. And the second one will be taken by Professor S.K. Singh from CII Roorkee, and he will be deliberating on precast sandwich panel system. Tuesday, which is the 5th day, it will be first session will be steel structural system by Professor Subrata Chattopadhyay from IIT Kharagpur, and the second one will be by Professor Himanti Banerjee from IIT Kharagpur, and she will be talking about steel structural system. And today will be the first session at 5:30 will be LGSF, the light gauge steel frame system. Its introduction, concept and feature by Professor M. Madhavan, IIT Hyderabad. And the second one also by the Professor Madhavan from IIT Hyderabad. Again, he will be talking in detail about the LGSF system. The 7th day will be precast concrete buildings by Professor Amlan Singh Gupta from IIT Madras. And he will be talking about precast buildings, its introduction, and then methodology implementation and the precast construction. Again, the second session will be by Shri Shabbir Lokhandwala. He is from Slab Engineering Private Limited. The last day, final day, we will have three lectures. The first one is 3D precasting by Dr. Rajit Chaurasia, CBRI, Roorkee. The second one will be 3D volumetric system construction methodology and other details by Shri S.J. Vijay. He is the chairman of Salmon Leap and director Home Mission India. And the last session will be taken up again on the 3D precast volumetric construction by Shri Siddharth Sharma. He is representing SGC Magic Crate Private Limited. And this will be the schedule for the next 8 days. And then at the end of after completing all these sessions, we have kept a examination for you, which will be MCQ, multiple choice questions based, and you can attempt that questions within 45 days of completion of this course. After that, you will be receiving a certificate from BMTPC. With this background, I would like to introduce our Executive Director for taking the first session. Dr. Agrawal, he is PhD in Earthquake Engineering from IIT Roorkee and Master of Science from BITS Pilani and MTech Structural Engineering from IISc Bangalore, and he has done his BTech in Civil Engineering. He was a silver medalist also in 1986 from GB Pant University. Presently, he is the Executive Director of Building Materials and Technology Promotion Council, which is under years. Before joining BMTPC in 2008, he was a scientist in CBRI Roorkee, where he served almost 19 years before joining BMTPC. He is felicitated by the Institution of Engineers, Roorkee local chapter for outstanding service to nation on 25th day of April 2008. Felicitated by Center of Excellence in Disaster Mitigation and Management, IIT Roorkee, for his significant contribution in disaster mitigation and preparedness in 2010, and felicitated by the Institution of Engineers as eminent engineering personality in the field of civil engineering in 2012, felicitated as outstanding public officer in the 8th CIDC Vishwakarma Award 2016, and Gem of College of Technology 2019, GB Pant University. With this background, he has been involved presently in Pradhan Mantri Awas Yojana extensively, and as an Executive Director of BMTPC, he is handling so many projects here and heading the organization. With this background, I would request Dr. Agrawal to start his presentation. Dilip ji, we can start the presentation.
Start the lecture today. Will, as I told you in the beginning, that today I will be introducing you all these emerging construction systems. Okay, and from tomorrow onwards, whatever construction systems I am explaining you, we have categorized them into 6-7 categories. Okay, and those 6 categories, each category will be dealt separately each day. Okay, for example, tomorrow we'll be talking on customized formwork. The next day we'll be talking on stay-in-place formwork system, then steel structure system, then light gauge steel structure system, then precast concrete construction system, 2D and 3D. Then we will also be touching on the new age technology, 3D printing. Then sandwich drywall construction will be dealt one day. Okay, there is another word called construction system. I'll come to that later, but just let me show you this slide before. You might be wondering that why all of a sudden we are talking about new technologies, new construction systems. So this is just a slide to explain you why do we require these new construction systems. Okay, see, we are fast urbanizing. India is urbanizing very fast. Okay, and this urbanization, is through Census of India, and every 10 year we have a census. So last census was done on 2011. That time 31% people of India live in urban areas. So if you see here, so 380 million people live in urban areas in 2011. And if you look by 2030, it will be 40%, and by 2050, it will be 50% population of our country will live in urban areas. That amounts to 815 million people. 815 million people means 81.5 crore people will live in urban areas. So the question to be asked, do we have sufficient houses? Do we have sufficient infrastructure? Do we have sufficient paraphernalia to support that kind of urbanization? And if we have to meet the aspirations of this growing population, we have to build very fast. Okay, so I'm introducing a word very fast. We have to do some. We have to introduce technologies which can deliver houses and infrastructure fast. So speedier construction system. Okay, so otherwise, if we do, if we follow the business as usual approach, or the way construction is being done, all of you know how construction takes place. It takes 2 years, 3 years. That we cannot afford. If we want to meet the aspirations of growing population, if we want to cater to this growing population, we have to introduce expeditious, speedier construction system which can help deliver houses and infrastructure at a faster pace. So we have to fast track the construction. So these all construction systems which we will be explaining to you, fast track the construction time. Or fast track the construction means the project which was to be completed in 2 years may get completed in 1 year, 50% time. And this is something I'm telling you is not theoretical. Already you can go to our YouTube channel and find in 45 days, a 7-story structure was constructed by L&T. 1,20,000 square foot built up area was constructed in 45 days. That's the building of Ministry of Defense, and which was inaugurated by Ministry, Honorable Defense Minister. Then a hospital during COVID time was built in 70,000 square foot built up area. G+3 structure was built in Tamil Nadu using precast concrete construction during COVID time. Then very recently, L&T and other companies, they have constructed 96 dwelling units, means 96 apartments of 2 BHK in 96 days, complete finish. Okay, and in one of our project, which I'll be showing you, Lighthouse project, which we just completed few days back, 26th of this, 19th of this October, that project was handed over by Honorable Prime Minister to the beneficiaries. There, 208 dwelling units. Each dwelling unit comprises of around 40 square meter length area. Those 208 dwelling units were completed in a time of 45 days. So that is the kind of speed you can get. And when we're talking about speed, in no way I'm telling that these construction systems speedier means they are low quality. They in addition they give better structural and functional performance. So they are better in every sense, whether we talk about structural performance or whether we talk about functional performance. Also, just to give you some stats, you can just see what we have written, what is written here in this rectangular. If we have to cater to this growing population, we are fast urbanizing. 380 people in 2011. By another 10 years, it will be 59 crore people will live in urban areas. So to cater to this urban population, growing urban population, India has to build 600 to 800 million square meter urban space every year till 2030. Means till 2030, we have to build a new Chicago. Chicago is a city in USA. So a brand new Chicago we have to build every year till 2000. So next 10 years, 8 years or so, we have to build a city like new Chicago every year. So I'm just taking a pause. Just think about it. If we want to cater to this growing population, we have to build a new Chicago city every year. Can it be done the way we do our construction? Just ask yourself. The answer would be no. So we have to employ techniques methodologies, processes, materials which can help construct faster. And I will show you, nowadays, you can just um, make a house, make a structure, and transfer it to the site and start using it. Okay, so that kind of technology is available. So we have to make use of that information. And also, already these systems which we'll be talking to you are already being used, being practiced, they are already proven across the globe. And what we are trying to do is we are trying to bring them to our country and adapt them suiting to our geoclimatic conditions. Also, just to give you a few things that we all should feel proud that India is, one of the largest and fastest growing economy of the world. You might have heard in the news that India has beaten Britain, and now we are the fifth largest economy in the world. And our honorable Prime Minister aspires that we should become very soon. We should become Right now, we are $3 trillion economy, and very soon we will become $5 trillion economy and $10 trillion economy in this Amrit Kal. And to become that $1 trillion economy, you all know that our sector, construction sector, has to play the most important role, because all of us know that construction sector, contributes to GDP significantly. Okay, so and when we are going to become $10 trillion economy, and we are fastest and largest growing economy, the construction sector has to play a significant role, and we have to employ technologies, materials which are innovative, productive, effective, and which can help bring speed to the construction. Also, sustainability is also very important. Nowadays, everybody is talking about climate change. We are talking about temperature rise. We are talking about zero carbon development. We are talking about less greenhouse gas emissions. So we have to have technologies which can help us in all these areas. Okay, and all these construction which we are going to talk to you, some way or other, they help in energy efficiency, eco-friendliness, disaster resilience, resource efficiency, climate resilience, and things like that. Okay, also, I wanted to tell you that always, whenever we talk about new material, new technologies, or new process, always think of this 3S mantra. Okay, so it is like a month for for our fraternity who are into building and infrastructure. Skill, scale, and speed. So if we want to take our country to next level, we have to bring in new sets of skill, and we have to bring speed as a factor, and the kind of skills we have. Sometimes I find that people come to me and ask, sir, in Singapore they have done this, in USA they have done this, but look at the kind of scale we have. I will show you one slide. In India, in urban areas, there is urban housing shortage of more than 1 crore. So 11.2 million houses are required in urban areas for EWS, for economically weaker section. For economically weaker section, the urban housing shortage is 1 crore houses. So that kind of scale. So whenever think of technology, think of scale, the kind of scale we are dealing with. And whenever we do a civil engineering project, we talk about cost per square meter. But in times to come, in your future projects, speed will also be a deciding factor when you talk about technology. That what technology or what material or what processes can bring in speed to our construction. How can we reduce the construction time, if I have to put? So always remember skill. And so to build new India, we have to acquire or learn new sets of skills, and we have to bring in speed somehow or other. And the kind of skills we deal with are, you suppose we have any innovative product or innovative technology, but it has to be replicated in the kind of skills we are dealing with. Okay, so that scale is also important. So remember this 3S mantra for new technologies: skill, scale, and speed. So if all these technologies pass through this 3S mantra, then the technology is good. Okay, so this is just a slide because I come from Ministry of Housing and Urban Affairs, and we are dealing with Pradhan Mantri Awas Yojana Urban. All of you might be knowing, but just to tell you, because this is a course that Government of India in 2014 when the present government took over, they aspired that by the time by 75th year independence, we should, all the households in our country they must have a pakka house. Okay, so two schemes were launched. One was for urban area, and other one was for rural area. So urban area scheme was called Pradhan Mantri Awas Yojana Urban or Shahri, and the rural was called Pradhan Mantri Awas Yojana Rural or Gramin. And since I come from Ministry of Housing and Urban Affairs, which deals with um, urban areas, so we are dealing with this urban housing scheme. And you all feel proud that when we started this mission in 2014, the urban shortage, which was given by the various state governments, was 1.12 crore houses were required. And we have already sanctioned more than that. 1.22 crore houses have already been sanctioned, and more than 1 crore houses have already been grounded. Grounded means they are at different stages of construction. And already more than 63 lakh houses have been completed and handed over to the beneficiaries. And these all are houses catering to EWS and LIG section. EWS means the poorest of the poor, economically weaker section, and lower income group. So 63 lakh houses in urban areas have already been given to poor. And if I have to give you stats of rural, there are more than 1 crore houses have already been built and given to the poor. So that is the kind of scale we are dealing with. So think of technology, think of that scale. We have to build more than lakhs of houses. So many houses are to be constructed. So what is the most suitable technology which can go everywhere, which can be replicated anywhere in our country? Okay. So this is just a stats to give you. Also, out of these 1.22 crore houses sanctioned, out of this 1 crore houses which are grounded, 16 lakh houses, 1.6 million houses are being constructed with new technologies. So whatever technologies we are talking to you. So it's not that I'm talking to you theoretically. We are implementing these new technologies in the field. We are building. There are several schemes, by Government of India. One is demonstration housing project, lighthouse project. I will be showing you those slides. Through these projects, we are trying to showcase the new tech, because this is first time these technologies are being used. So Government of India, through its own funding, is showcasing these technologies in different parts of the country, so that our fraternity, artisans, policymakers, all of us get sensitized and see through our own eyes the actual implementation in the field. And also, we do organize training programs, sensitization programs, exposure visits to the sites, so that you can just go and see yourself how that these technologies are being implemented. Also, this effort of government of building houses and all create a lot of employment. All of us know that construction sector generates, employs people directly or indirectly, and all these sectors. It's not about material, cement, steel, and other, but there are indirect and direct, potential of employment through the construction, and more than 2.5 crore employment have been generated through this. And this is just to give you the steel and cement consumption through these projects. Okay. So this was just a slide to give you stats, and why I showed you this slide, because through this Pradhan Mantri Awas Yojana Urban, only this our quest or our journey towards new technology started. Because when we started this mission, we thought that if we continue to build the way we build, we won't be able to achieve this kind of target, and we have to employ techniques and technologies which can help expeditious construction. So we started looking around the globe and could evaluate, shortlist number of technologies. So under Pradhan Mantri Awas Yojana, this entire effort, this NAVARITIH program, this our journey towards new technologies, certification, all these things are being done under Pradhan Mantri Awas Yojana. We are also handholding state governments, and now majority of departments, whether we talk about defense, whether we talk about railways or other LE departments, all of them are going for these new technologies. Public sectors, private sectors, everywhere these new construction systems and new technologies are being used, because they impart not only speed but also give better structural and functional performance, better quality, durability, and other advantages. Now, let me just give you this, because if you look at this, you might be thinking, why I'm not talking about material? All the time I'm telling you construction systems. So construction system means what? System means like, in our body we have skeleton. What is skeleton? Skeleton, is the main load carrying member of our body. The skeleton of our body helps us move around, stand around, and if we stand, the load of the body is transferred through that skeleton. So skeleton comprises of what? Of bones, a structure of bones, then those joints and all those kind of things. So consider the skeleton of a structure. So what is the skeleton of a structure? That is called construction system. Okay, so skeleton of a building is what? RCC frame. RCC frame means reinforced cement concrete beam and column and slab. Okay, so beam, column. So what you see here, this is beam and column. So this is the skeleton, or this is called construction system. So this is the main load carrying construction system or framing of the structure, which helps in transferring the load of the building safely to the ground through this construction system. So we are trying to replace this construction system. So there are two kinds of construction systems which are popular or which are prevalent around the globe. One is, you all are familiar with this, which is cast in situ RCC framed structure. Another one is load bearing structure. Load bearing structure means where you don't have these beams and columns. Instead of that, you have load bearing walls, and those walls are made of bricks. Okay, brick and mortar. So you have load bearing wall, 9-inch thick wall, and that is the load bearing wall, and over that you lay the slab or a floor, and the load of that floor is transferred through those walls to the foundation, and through foundation to the ground. So the construction system for this upper figure of a load bearing frame is wall, so walling system, and for this RCC frame is this RCC beam and column system. So we are trying to replace these construction systems. Can we have other construction? So immediately to your mind, if we replace this cast in situ RCC frame by steel structure, so can we have steel girders? All of you know about steel girders. So can we have steel column and steel beam, which are made in the factory? You just transport them to the site, and over the already laid foundation, you just erect beam and column. So you are just replacing that cast in situ RCC frame by steel. Also, or otherwise, you can make these columns and beam in the factory or in the casting yard. Make them there, okay, and then bring them to the site and erect them and just connect them or assemble them through jointing process. So that is called construction system. So we are trying to replace construction system. So conventional construction systems are of two kinds. One is the load bearing structure or load bearing construction system, where you have walls of brick or other block masonry, brick or a stone block masonry or any other masonry, and then you can have a floor or slab of RCC, or it can be truss, it can be sloping roof. Otherwise, the most common other system is cast in situ RCC frame structure. Then you have infill walls. That infill wall can be of brick masonry or stone masonry or any other thing. And then you have cast in situ slab. So we are trying to replace these two systems. And why we want to replace this system, I will show you in next few slides, because all of you know these are slow track construction system, a lot of noise, a lot of dust pollution, the cement, use of cement, steel and other things, a lot of water is being used. It is time consuming process, slow process, greenhouse gas emission, whole lot of things. Efficiency is less, then it is weather dependent, whole lot of things are there. So therefore we have to, like, for example, we talk about brick, so you use topsoil, then brick is burned. For that burning you require fossil fuel. Similarly, in cast in situ you require water and all those kinds of things. Okay, so that is why we want to replace these two systems by some other system. So this is understood. We want to replace our conventional or prevalent construction systems, which are these two, by some other thing. What about, instead of having wall of brick and mortar, we get a wall from the market. So we will have lecture. There are dry wall construction where you all know about sandwich fiber cement board support. That is not non-load bearing, but there are sandwich wall panel systems which are load bearing, and you can make as high as 4-story building using those the wall panels. So what about getting a panel from the market, or in a factory you produce panels and bring to the site and just erect that panel. So your wall is ready, your structure is ready. Okay, so just think about this, and so we replace this brick masonry by those dry wall construction. Similarly, this cast in situ RCC frame by factory made building component. Okay. Also, let me give you the example of metro. All of you know about metro. All of you know nowadays how bridges or how culverts and all those things are being constructed. For metro they make big piers, and then one fine day they will you will find a big trailer bringing a girder. Okay, and that girder is placed over those pier, and your track is ready for metro. Okay, so similarly, can't we try same kind of thing in housing? The answer is yes. So instead of making these beams and columns at the site, make them somewhere else and bring them to the site, and you know the advantages. There's no dust, speedier construction. You can efficiently use all your materials. Okay, there is a whole lot of saving. Quality can be achieved because you are doing everything in the factory, and you just bring them to the site, assemble them, and then put the walls. Those walls can be drywall or whatever. Slabs can be made in the factory. So whole lot of things. So the thing is, take the construction from the field to the factory as much as you can. So whatever you can do in the off-site or in the casting yard, do it there. Bring it to the site, and leftover you can do at the site. In fact, there are technologies where you can make the entire house. The entire house with 70 to 80% finishes can be made in the factory. And this is not something I am talking to you fictitiously. This is already being done in our country as well. Okay. So, I hope you have understood this. What do I mean by conventional construction system? And if we continue to use this system, there is another word, business as usual approach. And through this NAVARITIH course, or whatever BMTPC is doing, and whatever we are doing at Ministry of Housing, we are trying to bring this paradigm shift, or you can say technology transition in the sector, by replacing these age-old traditional systems by these new construction systems. Okay. Also, this is a slide just to add to this. You all know there is too much dependency on cement, aggregate, and water. All of you know sand has become scarce nowadays. Water is also scarce. So we have to. I don't say that don't use water, don't use cement and aggregate, but use them efficiently. And all of us know when collect the material at the site, we keep on adding water, we add the aggregates the way we want. Nowadays sand is also not available. You might have you might be knowing that cement manufacturers, they are making sand. Have you heard of making manufactured sand? It is called. Earlier we never thought that sand is a natural product which can be obtained from the rivers. But nowadays sand is also being manufactured. Manufacturing is through stone dust, sand is being produced. So why it has happened? Because we have been using sand as a as a natural product which is available in abundance, which is not the case. There are few states where sand is not at all available. Then few states have already banned mining, and you don't get sand. So you need to have alternative to sand. Okay, and why this happened? Because by following this business as usual approach, because we were using these materials which we thought we have in abundance, but it's not the case. Same is the case with cement. And cement, all of you know, cement is based on limestone. Limestone is a rock. So the way we are urbanizing, the way we have the kind of skills we have, there will be scarcity of cement. So because it is based on a finite resource, which is limestone. Okay, so we have to use these materials efficiently. So resource efficiency. So let me coin the word resource efficiency. Use cement, but use it efficiently. Use aggregate, but use it efficiently. Similarly, water. We used to say that water is a scarce commodity. Now, sand in construction sector, there are, if you Google, you will find films on sand wars. So there will be next war will be fought on sand because sand won't be available anywhere. So it has become a precious commodity, which we were taking, sand, we were taking for granted. So sand is not available, fine aggregate, even coarse aggregates. Nowadays, we have artificial aggregates. Okay. Similarly, during COVID time, we found that a lot of laborers, unskilled, skilled laborers migrated to their hometowns, and there was all of a sudden there was scarcity or shortage of labor, and all the projects came to standstill. Okay, so how to bring in human resource efficiency? It can be done if we have construction under control condition in a assembly line kind of production, or in a factory. Also, all of the construction is not of quality, because when you do it in at the site, cast in situ, sometimes quality is being compromised because we don't have qualified engineers or supervisors who can overall supervise the quality of the construction. Also, this is also the call of the day: green or sustainable development. Whatever we do has to be green. Green means it has to be eco-friendly, it has to be energy efficient, it has to be dust and dust-free kind of thing, energy efficiency, eco-friendliness. I will show you another slide where I'll try to define green in my own words. So green means resource efficiency, then it means climate resilience, disaster resilience, then your less greenhouse gas emission, then energy efficiency. So whatever sustainable as we are talking about. So you just can't keep on using brick, because brick is made of topsoil and it is being burned. So it has to be like make use of waste materials like fly ash and other waste materials. Can they be used in building construction? So those kind of things are to be incorporated in our construction activities. So any construction or any infrastructure we develop or build, it has to be sustainable or green. So to account for all these things, to make use of these materials efficiently, and also to bring in quality, durability, and to have sustainable development, it is need of the hour that we bring in these innovative construction systems. Okay, this already I covered in detail. In times to come, this will be the deciding factor. Every time we are talking about cost, but in times to come, there will be, speed. So the project, how much time you will take to complete the project? Right now, if I ask you, all of us will say, sir, it will take around 2 years or maximum 1.5 years. But can it be done in 6 months or 1 year? We have already done 2 projects, which I will show you. 1,000 dwelling units in Chennai we made in one year, despite of COVID time. And another project we have completed in 15 months. Just now, in 15 months, 1,008 dwelling units in S+13 configuration in Rajkot. So slow track construction, okay, has to be replaced by fast track construction technique. This is that green I was trying to talk to you. Everybody talks about green rating and all. So I just thought that I will, explain you to my understanding what should we do for green thing. Green thing means resource efficiency. Resource efficiency means like use cement, but use cement, sand, aggregates, steel efficiently. So bring in resource efficiency means just don't keep on adding cement water to make your concrete workable, and keep on adding water for curing. Whatever right amount of water, right amount of mix, whatever is required, use those materials judiciously, because these materials are scarce and there is shortage of these materials. And so how it can be done? It can be done, if you do the construction under controlled condition. Okay, so do the construction off-site. So abroad it is called off-site. In our country, we can call it in the factory, or in a casting yard. So the moment you do casting in the casting yard, you are bringing a lot of things. Resource efficiency not only in terms of material, only in terms of workforce as well. You all know if there is inclement weather, if there is problem of there are festival seasons, there are rainy days and all those things, and your work comes to standstill. But if you are doing same thing in the factory, continuously around the clock, you can work. concurrently you can work at the site and at the casting yard. So that will bring in resource efficiency. Okay, and another thing for resource efficiency is like let me give you the example of automobile industry. Then have you ever visited a plant of a car or of any other plant? So there they have an assembly line production. Each person is given a responsibility that you will put this part, you will put this part, you will put this part, and there is an assembly line. Assembly line means it's a path. So one first person will put a chassis of a car, then another person will put a battery, another person will put a upholstery, and those kind of things. And at the end, you will get the car made. So that is called assembly line industrial production, and that bring in resource efficiency, everything. So that kind of assembly production, need to be brought in the construction sector as well. Okay, second is energy efficiency, because if you are using cement, if you are using steel, you are transporting everything to the site, and then a whole lot of energy is being wasted. Then we are too much dependent on fossil fuels. Can that be avoided? So bring in processes, or bring in materials which have which require less energy. Okay, so energy efficiency, I'm not dealing with that much, but there are three kinds of energy which are required. One is embodied energy. The energy required to make the material. Okay, that is called embodied energy. Then is the transport energy required for transportation, and then the energy, operational energy. Then once the construction is done, the energy required to operate that structure of that building, that is called operational energy. So the majority of energy is consumed during operation of a building, during its maintenance, during its lifetime. So that energy efficiency devices and those kind of things need to be put in your structure and building, so that overall energy consumption during the lifetime of a building is less. In resource efficiency, another thing is waste. Right now there are a whole lot of materials which are available, waste materials. All of you know about fly ash. When we studied, we never knew about fly ash, but nowadays fly ash is directly added into this cement. Okay, so you can replace up to 25% of cement by fly ash without compromising its properties and strength and all those things. So just imagine 25% precious cement material you can save by just replacing that cement through a waste material which is fly ash. So that brings in resource efficiency. So in fact, whole lot of waste materials have already been slag cement, whole lot of slag. Slag is a waste product of steel industry, so that slag can be efficiently used. It can be mixed. Slag cement we all talk about. Then waste material, C&D waste. Through C&D waste, there are a whole lot of plant right here in Delhi. There are plant operational where that C&D waste can be gainfully utilized to make sand, coarse and fine aggregates, paver blocks, and other kind of blocks. Okay, then eco-friendliness is less greenhouse gas emission. Then can we use materials which are friendly to nature? There is less dust. You all know, like if I give you example of Delhi, in Delhi, if your air quality, right now the air quality is worsening. So once the air quality index reaches to a threshold, then we stop the construction activities in Delhi or other metro megapolis cities. Okay, why? Because we all know that construction activities generate a lot of dust. So can that dust be avoided? Yes, that can be avoided if we do the construction in the factory. If we make those, instead of cast in situ construction, we do that in the factory or somewhere else, or we employ dry wall techniques and all, we can have less dust at the site. Okay, similarly, a lot of waste is generated at the site. There are countries around the world where when you do a project, there should, whatever waste you generate during construction has to be consumed in the project itself. But when you come out of that project, there should not be any waste, and all that waste should not be dumped anywhere. It has to be used in that project. So there are processes, techniques available where you can in fact, the government of India did, our own organization, CPWD and BCC, they did a project, in Delhi, in front of AIMS. You might have seen, if you are from Delhi, if you are conversant, that there were old government accommodation that was demolished, and a new high-rise structure for government officers accommodation has been created. So whatever, when those old structures were knocked down or demolished, whatever waste was, that construction demolition waste was converted into blocks. Okay, so there was an Egyptian Israeli technology. So they brought their own plant to the site, and whatever construction waste was generated, demolition waste, that was converted into building blocks. So that kind of thing is required. And also, let me tell you, so that all of you understood this: resource efficiency, energy being consumed during operation of a building, resource efficiency in terms of material, in terms of labor and use of waste material, eco-friendliness means less greenhouse gas emission, less dust pollution. Can we use all of us know about wood and all? Can we use plantation timber and other kind of things? Eco-friendly materials can be used in the building. And there is another dimension to construction nowadays, which is health. Have you ever thought that what kind of adverse effect our construction have on the occupants? We take cement concrete for granted. We take our construction for granted, that everything inside the house is good. The air which we breathe inside is good. But let me tell you, there has been several studies which say that inside air quality is more poisonous, more detrimental to health than the outside air quality. Think of it, air quality index. We are all claiming that air quality index is worsening, and it is worst, or it is back to worse. What about inside air quality? Inside air quality is more poisonous because the kind of pesticides, the kind of treatment, the kind of paints, varnishes we are using inside the house, that pollutes the inside atmosphere of our house. So health of the occupants is also very important. In fact, in one of the slides I will show you, there is a company from UK. They are making, they are called Nano Living Board. Nano Living Board means that is a MgO board drywall, and they say that MgO reacts with the carbon dioxide inside carbon dioxide, thereby creating healthier environment inside. Just think of it. That kind of thinking has gone into construction. Make a house which can bring in fresh air, or can help improve the inside air quality. And that is why you might be knowing, if you are dealing with GREHA rating and the green rating systems and all, that they emphasize or they stress use of paints and varnishes which have low VOC, volatile organic compound. Because whatever paint, whatever plaster, cement, whatever we are doing, they are constantly emitting organic compound, fine organic compound, which have adverse effect on our health. So to improve that health, what kind of material, processes and systems we can use? So always remember these four things whenever you want to select any material construction. So resource efficiency, energy efficiency, and this is the whole ambit of green aspects. Also, just to give you some stats, this is again, there have been a systematic study by the Energy Research Institute and GREHA, which is one of the rating system in our country, that buildings consume 40% of precious energy and 25% of precious water and 40% of natural resource. Construction activities consume this much of our precious resource. Okay, fine, if they consume, but at the same time, they contribute 50% to air pollution, 42% of greenhouse gas. Greenhouse gas emission, greenhouse gases, all of you know, like CO2. Okay, carbon dioxide is the main culprit of greenhouse. So whatever, suppose we are producing cement, so each ton of cement produces 0.9 ton of CO2. So can we have techniques which can reduce greenhouse gas emission? Then 50% of water pollution because of building activities, and that is why nowadays recycling of water is being stressed. STP is being advocated, recommended, so that whatever water being polluted has to be used again. It has to be recycled, and 48% of solid waste. Okay, so building activities consume precious energy resource, precious water, and precious natural resources, which is limestone, topsoil, fossil fuels, and the whole lot of other things. And at the same time, these contribute, pollute our air by 50%, contribute to the greenhouse gas emission, water pollution, and solid waste. Okay, and so this has to be reduced, and how it can be reduced? By bringing these new systems. And so this was the whole premise. So why new technologies? So to bring it uh, by using these sustainability aspects on this, you can reduce 30 to 50% reduction in energy. We don't 40% reduction in water use, 35% reduction in greenhouse gas emission, and 75% reduction in waste. Okay, so just by using these innovative emerging construction systems and by employing um, emerging processes and technologies, you can um, um, have sustainable buildings, and thereby reducing 30 to 50% energy, 40% water use. And this is just a stat for you. And at the same time, I already covered this. Why do we require new technologies? To bring in speed, because speed is the need of the hour if we want to take our country to one of the fastest growing economy. Okay, and if you want to build new young India, you have to bring in speed. The way we are organizing, so speed is the guiding force for us when we talk about technologies. Then quality. At no point of time, I'm telling you that speed means leave other factors. So quality is of paramount importance, and all of us know every day there have been cases of the collapse of buildings and then losses of life and properties. Every day you will find in newspaper that they're because of the bad quality of construction, poor workmanship. So by employing these new technologies, you can improve quality drastically. Okay, safety is also very important. Safety, not only the safety of the workers at the site, but safety means whatever we build has to be safe against natural hazards. Natural hazard means earthquakes, floods, cyclones, fire. Fire is not a natural hazard, but safe. You have to create a structure which is disaster resilient. Okay, and sustainability. So as fresh or new engineers, graduates, architects, you have to bring in techniques, quality, materials, and technologies which can help in sustainable development or green development. Okay, that means energy efficiency, eco-friendliness, health of the equipment, resource efficiency, less greenhouse gas emission. Okay, then life cycle cost I will just cover, but before that, thermal. See, most of the time when we talk about these new technologies, every now and then we are flooded with questions. Sir, what about fire? You are giving thin sections, so functional performance. In no way the functionality of building is to be compromised. So whatever, whenever we talk about new technology, it has to be compared with the conventional construction. So 9-inch wall versus 4.5-inch wall. No point of time thermal efficiency, sound, the insulation, fire the rating, or all these things are better than your conventional system. Okay, so functional performance, and at no point of time is being compromised when we talk about these new technologies. Okay, so speed, quality, safety, sustainability, functional, and better structural performance. There is another thing is life cycle cost. Uh, Whenever we take up a new project, what do we say? Everybody will ask you, what is the cost? So that cost means initial cost of construction, cost per square meter, or cost per square feet. So we always talk about this is the cost per square feet, the total cost of building will be this, and my project will cost this much. But nowadays, that word, to bring in sustainability, that word is being replaced by life cycle cost. So, and life cycle cost is nothing but summation of initial cost, the cost which we keep on talking. Initial cost means cost of construction plus operation cost of a building. We are all the time ignoring once the building is made, you are taking that building for granted. But during its lifetime, during its service life, how much cost is being incurred for its maintenance, for the kind of appliances you are using, the kind of energy building is consuming, the kind of waste it is producing. So what that is called operational cost of it. And do you believe that operation cost during the service life of a building goes more than 4 or 5 times than your initial cost of construction. Just think. So operation cost supersedes your initial cost of construction, and we are bothered about initial cost. So it may so happen that initial cost you may say that this is this much, but during the lifetime building may cost more. So that cost also need to be thought of when you plan a building or when you plan your structure. And there is another cost to it. That is disposal costs. Once the service life of a building is, have we ever thought of that? Once the service life of a building is over, how that building is going to be demolished? Will it be detrimental to the environment? How those, whatever material is being demolished, how it is going to be used? Will it be thrown just like that, vitiating the environment, vitiating the Mother Earth, or can it be reused? So that is called demolition or disposal cost. That also need to be accounted for if we want to have sustainable development. Okay, so nowadays, for bigger projects, everybody's, so there are techniques, tools available which will give you life cycle cost. So don't think of initial cost, but say life cycle cost of a building should be minimal. Initial, which is a summation of initial cost plus your operating cost of a building plus its disposal cost. And that is why in government sector, now we have introduced this life cycle cost, and there is a circular which says that for a project of the project of certain size or higher, you need to account for life cycle. So whenever we talk about these new technologies, think of life cycle cost, and life cycle cost has to be minimized if you want to go for sustainable development. Okay, so all right. So this is about all about why do we require new technologies? Speed, quality, disaster resilience, sustainable development, and the better functional and structural performance. And once we employ these new technologies and all, it can help us in all these things which I talked to you in detail. Okay, so this was the background which I wanted to give you, that why do we require new technologies, or why do we have to think out of box? The way construction is taking place, the way we construct our buildings infrastructure, that will not serve the purpose because of the reasons I just explained you through these slides. Okay, and if we want to, India is signatory to Paris Agreement, India is signatory to climate change mitigation strategies, and by 2070 we have to have zero carbon footprint. Whatever we do, there should not be any greenhouse gas emission. Okay, so if we have to achieve all these things, we have to drastically change our construction practices. We have to change our material, our products, all those things. Okay, so through these slides, I wanted to give you the background that this is the time when we take a shift, or bring the transition in, bring the transition the way we construct. Okay, now this is the slide. Now, having said so, now let me show you this slide. This slide shows you the levels of construction technologies. And now, if I will just pause for a while here, just to make you understand that you just see this slide and try to find out at which level we are, or normally which is the most obvious, or which is the level you see most commonly in our country. So that is level 0, isn't it? So what we do, level 0 means we collect the material, we bring the cement, sand, steel, mixer, formwork system, a whole lot of equipments and all at the site, call the contractor, then start doing the excavation, do the formwork, put the reinforcement, put the slab, do the curing, do the finishing. So that is level 0. Now think of this level 1. Level 1 is, you might have heard of pre-engineered building, or institutional buildings or industrial buildings, where what they do, they make, they make the process and all in the steel trusses and all are being made in the factory, and then those trusses are put over the already built columns or steel columns. So that is called level one. Okay, so pre-engineered buildings. Okay, so normally these are the two levels. Okay, level one is for structure, level one, and then level two. Now just imagine, instead of this, if we make elements of a building or a structure, what are the elements of a building? Beam, column, slab, wall. So make them somewhere else in the casting yard. So those are called, prefabricated elements. So those prefabricated elements are made in the factory or off-site or in a casting yard and brought to the site. So you can save on a whole lot of things and just transport them to the site and assemble them at the site, and you are ready with your buildings. Okay. Then level three is another step ahead. Here, what we are doing, we are making column, beam, slab separately. Instead of that, we make the entire, you can see this. So we make the entire building. So, there will be 2 or 3 presentations of these technologies as well in our coming lectures in this course. Okay, so last 2 days are dedicated to these 2 or 3 levels. Just think of this. So you see this is the module. So the entire room or entire dwelling unit or entire enclosure you make and then put one over the other. And in common language, it's called Lego blocks. Like as a kid, we used to play with building blocks. You remember? Plastic building blocks we used to have, and through those building blocks, we used to make the entire building. So similar thing. You make the building block in the factory, and then put one block over the other to create a multi-story structure. That is level 3. And level 4 is another step ahead, where here you are just making the enclosure, cement concrete enclosure. Here you put the finishes as well in the factory or in the casting. And finishes means you do the plaster, you put the services, put the wash basin, put the seat system, you put the windows, you put doors, windows, everything, all services you put. So 70 to 80% work is done in the factory, and then you bring it at the site and start using it. And that is level 4. So here, this is a pre-finished house. So entire house, 80 to 85% work is finished in the factory, and the touch-ups you have to do and start using that house. That is called plug and play house. Plug and play house means plug and play devices. All of you know. Plug and play devices means like USB drive. All of us know about USB drive. USB drive is a plug and play device. Means the moment you plug that device to your computer, it automatically starts playing. Same thing in houses. Plug and play houses. You bring the house, connect it, plug it with the services, electrical and your services, water and sanitation, sewerage, and start using it. So that plug and play, and that is level 4. Now you might be wondering why I'm talking about level 2, level 3. You might be laughing, but the good news is all these levels exist in our country. There are more than a dozen companies in our country who are at level 3, level 4, level 2. For level 2, there are more than 50 companies. Level 3 and 4, there are more than a dozen companies who are into level 3 and level 4. And we have lectures for you. In fact, we are doing a project where we are using this level 3 and level 4. In one of the projects, there will be lecture there will be 2 lectures who will be talking in great detail. So the good news is all these levels exist in our country. Already there are projects completed successfully by the agencies, by the contractors, by the technology providers using these technologies. Only thing is we are not aware of this, or we don't repose our faith or confidence into these things. That is why government has pitched in, we have pitched in, we ourselves are showcasing these technologies and trying to promote, trying to create a enabling environment through these lectures, through through teaching you and through hand-holding different stakeholders, so that the message goes everywhere and everybody gets exposed to these technologies, or at least get to know that these kind of things are happening in our country. Earlier, we used to think that these things can happen only abroad, but these things are happening in our country, and all we have to do is repose faith and make use of this information. And now, by this time, because by this time now, whatever I explained you earlier make sense. The moment we bring in these labels, we can, you know, achieve all those things which I talk to you: efficiency, resource efficiency, material saving, waste minimization, greenhouse gas emission, smart construction, speedier construction, then life cycle cost, disaster resilience, sustainability. Because the moment you make these are thinner sections, so you save on material. Whatever I talked to you earlier, all those things can be achieved if we, employ these techniques or these things in our construction systems. Okay, so I think now this is understood to all of you, and this is the humble, attempt by all of us, by Government of India, that let's take a jump from this level to this level. In fact, nowadays, even in villages, Andhra Pradesh government, they are making 1 lakh houses using, where they will give the kit. You might have understood DIY, do it yourself kit. So similar kit, can we have a similar kit for Pakka house? Yes. So you give them a kit where you will have a building elements which can be easily lifted by 2 or 3% and just put those houses. Only thing is, here for all those things we are keeping conventional foundation. So you have to come at a foundation level, and over that you can put these superstructures. Okay, so let's take a jump from level 0 to level 3 and level 4. And once we take that jump, we can achieve speed without compromising structure and functional performance. There is another thing which I wanted to tell you. This is another new thing which is coming. DFMA. Whenever we talk about construction, what comes to our mind? Contractor. So what we will do, we will give him the material, or we will give him the labor contract, or we'll bring the material, we'll give him the entire. That is called contract. Now that word is being replaced word over by DFMA agency, Design for Manufacture and Assembly. Design for Manufacture and Assembly means there are agencies available depending upon your project size, depending upon your requirement. They will conceive the project. They will, think of equipment and machinery. They will bring that machinery and equipment at your site, create a casting yard. They will, manufacture those components and all right there at your site, and then assemble. So those agencies are called. This is very popular in, US, Singapore, USA, and China. DFMA. So like you go to a tailor, and he, as per your size, as per your requirement, he customizes your jacket or your shirt or your trousers. Okay, so similarly for buildings, depending upon your project, the agency will come, they will bring their own equipment, they will manufacture. That is called design for manufacture, design for assembly. So remember this word, DFMA. Okay, so in times to come, you will be dealing with DFMA agencies instead of contractors. Then another interesting thing I have written here: manufacturing of buildings. What we do normally, we do construction of a building. We construct a building. The moment you replace that construction word by manufacture, so let's manufacture a building. The moment you say manufacture means you will think in your mind about industrialization or a factory set. So can't we make building in a factory? And there are factories available in our country where they are making all these components and the entire dwelling units. So let's replace construction of building by manufacturing of building. And this is also PPVC. There will be again a lecture on this also. PPVC means the same thing. This kind of thing, prefabricated volumetric construction. You might have heard nowadays, there is no need to make a toilet or a bathroom element. The entire thing is made in the factory. That is called pod element. Or nowadays, you can just order a toilet, or you can just order. It's called pod element. So that thing is called prefabricated, pre-finished volumetric construction. So the entire enclosure with roof and floor will be delivered on a tailor to you. So that is called PVVC. Okay, prefabricated, pre-finished volumetric construction. So it's a kind of room or entire. So instead of making 4 walls and putting a slab and all, you get that pod element from the from the agency. So that is called PBVC. So like you might, some of you might be knowing we have mobile toilets and all. Isn't it? We have mobile toilets whenever we have a big mela or event. There we put those, moving toilets. Okay, so those are made of steel and all, or tarpaulin and all those things. Similarly, for a building, you can have a concrete pod element. So pre-finished volumetry construction, which is done in the factory. So that enclosure is brought to your site and you can put in your house. Okay, so these are some new upcoming things. It's already there in our country now. Okay, and I thought you must be aware of all these things. And another thing is building information modeling. It's very, the promising area. Building information modeling means creating a virtual model in your computer. So you create a twin model. It's a twin. Whatever you are doing on the site, same thing is being done on the computer. So there is no need to go to the site. You are creating everything sitting in a room. So it's a virtual or twin model of a building. And everywhere in the world now, BIM is made compulsory. It's called BIM, Building Information Modeling, or BIM, BIM. So this BIM is made compulsory in most of the countries, and in our country also it's now coming up. And as professionals, you must learn BIM, because in future you have to create your building in this BIM software as well. And BIM software has a lot of advantages. Right now, suppose you are constructing a building, one day a planner will come, or that MEP person will come and you will say it is not possible to put an electric line, a pumping line like this. Please change this. So you have to make changes at the site, and thereby endangering the structural safety or integrity of your structure. Instead of that, you make entire thing on the computer, which all the stakeholders, all the MEP, architect, engineers, everywhere they make their drawings, and all those drawings are together synchronized in this building information modeling software to create the entire structure, and then those drawings are given at the site. Okay, so this is also very important. Now look at this. This is the another technology, and we will have on Sunday we'll have lecture on this 3D printing. 3D printing of a house, and this is the first two-story 3D printed house in our country, in India. I was fortunate to be part of this whole process. This was done in Kanchipuram. Kanchipuram is in outskirts of Chennai. It has a headquarter of L&T, and this building was printed by L&T. And as the name says, 3D printing means you all know about AutoCAD drawings, okay? So AutoCAD drawing, you just feed in a computer and just give a command, and you will get your house printed. So through a robot, through a equipments and all, your house, it is called additive manufacturing. So how will you print a house? What should be the ink? Ink will be construction ink. That construction ink is nothing but a special kind of concrete. So what you see, so through a robot or through equipment, these house will be printed like this, layer by layer, and you get that entire house made. So think of this. Already this technology has been successful. Bridges, culverts, special structures are being printed world over. And now this is coming in houses also. China, they have already printed several hundred houses using this 3D printing technology. And in our country also, right now research is being done, and is already L&T and other companies are into 3D printing of house. So this is the kind of innovation taking place world over, and in our country also. All we need to do is, uh, just explore these technologies, and as per our requirement, switching to our geoclimatic condition, we can make use of this information and use these technologies. Okay, so this is the first part of my lecture. After this, we will just have a break of 5 minutes, and let's say around 7:12 or 7:13 we will reassemble, and then I will explain you all these technologies category wise. Okay, so this was the background, and now after this I will explain you all these construction systems which we have divided into number of categories, and from tomorrow onwards you will have specialized lectures by experts for each of these categories. So let's break for 5 minutes, and okay. Yeah, yes, these technologies are registered with development authorities. DDA. Somebody is asking about this thing, but CPWD has already approved these technologies. PUDA, DDA. Yes, DDA, these technologies are approved, but PUDA, these technologies are not approved. But Ministry of Housing and Urban Affairs, they have issued the notification regarding use of these technologies. But India being a federal country, all states they have to issue their own circulars and all. But at central level, these technologies have been approved not only by Ministry of Housing and Urban Affairs, but also by CPWD. So most of these states they take CPWD's approval as the approval. Also, if you have difficulties, most of the states what they are doing, they are saying technologies which they are going to use in their future projects or in their projects has to be either approved by the Ministry of Housing and Urban Affairs or CPWD or BMTPC. So BMTPC is our organization which is being authorized by Government of India through Gazette notification to certify all these construction systems. So like Maharashtra government or Andhra Pradesh government, what they are saying, technology, whatever technology, at the time of tender, they write technology either approved by BMTPC, CPWD, or Ministry of Housing. And few states, they are also saying, if these three things are not available, it should be approved by some academic institution or research laboratory. Okay, so those approvals are sufficient for making use of that technology. Okay, so now let me start the rest of my lecture. So I will again share my screen with all of you. Alok, is it visible?
Yes, sir.
Okay. So, I think all of you got the background, and, whatever I told you, you should think of it seriously and with utmost sincerity. Because, I did my BTech in 80s. So that time, sand, pollution, nothing of that sort was being discussed. And now everybody is talking about waste utilization, greenhouse gas emissions, and these words are new words to us. But now the professionals who are in the field, they have to think of all these things, sustainability and all this. That is why we have to have new sets of technologies, new sets of processes, and we have to think out of box. Okay, we have to think other than routine or business as usual approach. Okay, and that is why we have shortlisted, evaluated, and assessed these systems. Also, it is not that these technologies are these are already proven. Let me also tell you that these technologies are already proven and time tested elsewhere in the world. So they have already proven their effectiveness for the construction elsewhere. All we have to do is adapt them in our country. So we have created a basket of these technologies, which I'll explain you. And what we have done, for the sake of clarity and for the sake of brevity, what we have done, we have categorized them into these categories. Okay, so this categorization has been done by me. So you can always question this, but just for the sake of clarity, what I have given a name: engineered customized formwork systems, the stay-in-place formwork. I will explain you pictorially in a very simple way all these things to you. Then precast sandwich panel systems or drywall construction, then steel structural system, and then precast concrete construction system, which is again divided into two. One is 2D planar elements of beam, column, or wall elements. Other is 3D volumetric construction, where you make the entire room. And as I told you, each day, one day we will have session on formwork, one day on stay in place, one day on drywall, one day on steel, one day on light gauge, and one day on precast is again divided into two. So 2D, 3D, so 2, 3, 4, 5, 6, 7. So these are 7 days for these technologies. And today is the introductory. So tomorrow stay in place, then next day stay in place, then drywall construction, then steel, then light gauge, and then 2D volumetric, 2D precast, and 3D precast. Okay, so let me just give you this. But before that, Again, sometimes structural engineers, civil engineers ask me that, sir, when you're talking about these new technologies, what about the mandatory requirements or given in courts and all those things? So let me tell you, all these technologies do not compromise with the quality of construction, cost, time, and all. So quality of construction is safety of structure, performance of structure, and durability. And with new technologies, whenever we are talking about these new technologies, we in no way we are violating our codal requirements. So whenever you want to use these technologies, these technologies have to satisfy our codal requirements or the stipulations given our Indian standards, national standards. And see, safety against anti-live loads, safety and stability with respect to uh, cyclones, wind loads, and other things, and other natural hazards, earthquake loads, snow loads. Performance of structure during its lifespan, thermal efficiency, acoustic efficiency, dam proofness. What do we see all these things in commercial construction? But here we are looking at all these aspects. Okay, efficiency of joinery systems. Sometimes joints are being questioned, so that in beam column joints, the joints are pakka, monolithic, and all. What will happen here, and all those things. So efficiency of joint, fire rating, fire resistance characteristic of structure is being said. Then durability. Now and then question is being asked, where you are using the sandwich wells. Now, what is its life as compared to the life of a brick wall or a cement concrete wall? So durability, deterioration of components, deterioration of structure with respect to with age or with atmospheric pollution. So all those things are also being seen. Okay, life expectancy of the building. Okay, speed, I already told you that you can reduce the speed, by 50%, 50 to 60%, and already it has been amply demonstrated by agencies in our country working under Indian conditions that speed can be reduced up to 50% using all these technologies. So what I have written, just let me just go through the traditional constructions being adopted around us is basically slow track construction and not amenable for mass housing. Okay, and on account of undue time taken, because once you have that cost time overruns, the overheads and wastages become quite high, leading to time and cost overrun. So once you complete the project well in time, your overheads are reduced, wastages are reduced. Okay, so then cost of construction, see, there is something called economies of scale. Let me also tell you, because you will be asking, in every course, all the time, participants are asking, sir, what is the cost? With every expert. So let me tell you straight away that cost depends on a lot of factors, but cost hovers around 10 to 15% higher or lower depending upon the economies of scale. You all understand what is economies of scale? Because these technologies are based on a factory setup. So you require certain amount of work. That is called economies of scale. Let me give you example of a manufacturing plant. Suppose you have to make 1,000 shirts or 10 shirts. So you have a factory setup. If you make 10 shirts, the factory setup is same. So shirt will be expensive. Instead of that, if you make 1,000 shirts, the cost will be divided on 1,000 shirts. So it will come down. So that is called economies of scale. So if we have more number of units, if we have more built up area, the cost will come down. So there is critical mass or threshold, which is called economies of scale. So if we have, say, 1,000 houses, the cost will be compared with the cost of convention. So that is very important. Also, as I told you, in today's context, cost is not per square meter, but cost is cost effectiveness, which is to be measured in terms of quality, in terms of time, in terms of environment, in terms of life cycle cost. So think of that cost instead of cost per square meter. Okay. This I already told you. Now let's come to these categories. One by one, I'll tell you. First is engineered formwork system. Okay. So I will begin with this formwork. All of us know what is formwork. Formwork is nothing but a mold, okay, temporary or permanent mold. It is sometimes of plywood, it is sometimes of wood, or it is sometimes of steel. So to give shape to your concrete, you bring the formwork from the market and put that formwork on the already erected reinforcement case. Suppose you have to make a column, so you will put four plywood or the wood or steel plates. That is called a formwork. So that is the normal formwork which we use. Traditionally, it is of timber, otherwise steel. So can we replace that form? So what we do, we make a formwork for beam, column, then for slab we put steel plates, then we put wooden bunnies, or we put steel tubes, and then we put the reinforcement, lay, do the casting, then remove after 14 days we remove the formwork, do the curing. So that is the business as usual. So think that instead of making the formwork for beam, column, slab, and the standard size of formwork comes, and you put a lot of alterations and all. And instead of that, if we make the formwork for the entire room together, and then do the casting of entire room together, you will save a lot of things. Okay, so that is called engineer formwork or customized formwork. Okay, there are other two kinds also, which I will explain you later. So this is this. You can see in this. I will take laser. Okay, you can see this. So this is the business as usual approach. What we have here, we have a this is a steel formwork and all. Instead of this, we have a customized formwork. So as per your project size, as per your project requirement, as per your layout, as per your architecture plan, this formwork is customized. Customized means tailor-made in the factory for you and given to you at this time. And what you do, you put the reinforcement, erect the formwork, lay, pour the concrete for the entire house together, and next day you remove this formwork and take to next floor. So that is why it is called. So you might be knowing it with my one. It is called aluminum formwork. So there are several names. As I was telling you that there is no standard name for all these technologies. It comes with several names: aluminum formwork, alu formwork. Otherwise, we know it with the name of My One technology. My One was the company, Malaysian company, which started this formwork, which started giving this formwork to our country, 10 years back. And now My One has shut their doors there in Malaysia. They have opened here. They have become Indian company, and there are more than 50 manufacturers of aluminum formwork in our country. More than 50 aluminum formwork manufacturers. And if you happen to visit the factory of a manufacturing formwork factory, you will be amazed. They are using robotics, CNC, and accuracy up to 0%, full accuracy, plus minus 1 mm, accuracy. With that kind of accuracy, this formwork is being produced, so that there is no margin of error. Okay, so you understood with this figure, we have this, and we want to replace this by this customized formwork. Okay, so replacing cast in situ formwork with factory-made customized formwork. This formwork is normally made of aluminum, and it has 100 to 500 repetitions. And this brings in assembly line construction. So what you do, you place the formwork, pour the concrete, first put the reinforcement, then place the formwork, then pour the concrete, then remove the formwork, take it to the other. Okay, and tomorrow there will be a lecture by ADGCPW, retired ADGCPW, Dr. K. Anthony on this, and then we have another special lecture by L&T. There is a formwork specialist from L&T who will be delivering a lecture on this particular aluminum formwork system, and will tell you everything about it. And if I have to tell you, this is the most widely used technology in our country. This is the most widely used technology used by public and private agency, and there is no problem. The technology is much cheaper than your 10 to 15% less than your conventional cost of construction. Only thing is, this is suitable when you have a mass housing. Mass housing means when you have a dwelling unit of repetitive nature. Same dwelling unit is repeated. So like when you are making apartments. So mass housing is what? When you have same apartment which is repeated several times. Okay, so modular construction or mass housing, this technology is very popular. Okay, so I think you understood this customized formwork based on your project is made in the factory, brought to you, and after your project is over, you can give that formwork back to the company from where you have taken it, at a 40% salvage value. Okay, so 40% money will be given to you because this is of aluminum, so aluminum is recycled, so it becomes clean also. Okay, you can see here. So you can see this. This is again a picture. I'm not showing you the picture from abroad. This is a picture from Indian. And as I told you, several lakhs of houses, Andhra Pradesh and Telangana. This is the technology most widely used under Pradhan Mantri Awas Yojana. More than 5 lakh houses are being constructed with this technology. So you can see. So this formwork is placed for the entire unit. Then in one go, the concrete will be poured. And first you are putting the reinforcement, and then next day you remove this formwork and take to the other floor, because they put self-compacting concrete, admixtures are being put. So all those things will be explained to you in tomorrow's lecture. So I'm not going into that. I'm just trying to give you the concept that what it is replacing and with what we are replacing. So fragmented formwork is being replaced by formwork for the entire modular unit. Okay. So you can see here, the conventional mode of construction is RCC framed structure with infill masonry wall. So here, but here all walls, floors, even staircases, everything is along with door, window opening, everything is cast together. So you don't need to make walls, and everything is monolithic. So there are no joints. So maintenance is less. And since you are doing monolithic entire casting together, so the thickness of walls are less. So for the same built-up area, you have more carpet area. That is also important. So concrete is very important for this, because you have to use spatial concrete, self-compacting concrete, appropriate grade of concrete is to be used for this. Okay, and being modular, pre-designed formwork system, it acts as an assembly line. I explained to you assembly line production means like an automobile industry. So assembly line production means every duty is assigned beforehand, that you have to do this, you have to do this, and then you have to do this. So that way you will you can have rapid construction of multiple units. It is just a closer look of that, and then I'll show you different stages. As I told you in the beginning, you might be asking this question. Right now, we are not promoting. We are, saying conventional foundation. Conventional foundation means, because India is a vast country, and every region we have different soil strata, different water table, different bearing capacity. Somewhere we have rocky terrain, somewhere we have black bottom soil, somewhere we have marshy land, somewhere we have alluvial soil, somewhere we have river beds, and also depending upon your bearing capacity, depending upon your biography, you can have foundation convention. It can be raft, it can be pile, it can be isolated footing, it can be continuous footing, it can be combined footing. And what you do up to the foundation, from foundation to plinth, you construct in a conventional way. So at the plinth, you leave these double walls, and from here, the actual demonstration of new technology starts. So, like the formwork system, you have reached up to this level, and then you put a plinth beam and dowel, and over this, you put this formwork system. Okay, for the entire dwelling unit or entire module, and then to the concrete. Okay. So understood? So this is like this, then this is this, this is this, it is how it is. Here you can see this is the finished house, with balcony, and sky is the limit, it is flexible, whatever shape you want to have, that shape can be achieved here. And since everything is being cast together, it's structurally very robust and efficiency, thinner walls and less joints, so less maintenance, better seismic resistance because there are no joints, reinforcement, and these are RCC concrete walls, so it acts as a shear wall as well. And this is already, as somebody was asking, it has been already approved by several agencies. There is, there is also schedule of rate available for this technology. This is also included in National Building Code of India. Okay. Then there is another variant of this technology. Here, what we are doing, we are making the formwork for the entire dwelling unit. So there are a whole lot of formwork which will be explained. So I showed you this is the most popular one. Then there is another one, tunnel formwork. So this is the technology which we have used in one of our lighthouse projects, which we recently finished in Rajkot. So here, instead of making 4 walls together, we make longer walls. So we create a tunnel kind of structure, and the remaining walls, which the shorter walls which remain, they are infill walls. Okay, so this has advantage advantages when we have longer structure in one direction. So this kind of formwork is being used. Then there are jump formwork, slip formwork. If you have to make a high rise, like Burj Khalifa and all, there they are using slip formwork. So 800-meter building can be made with this slip formwork system. So what they have a central shaft, and around this you have a formwork system. So you cast and then take it to next floor through hydraulic system, and then next floor, like that you can go as high as up to Burj Khalifa. So Burj Khalifa use the slip formwork system. In fact, the tallest tower in our country, the one in Gurgaon and one in Mumbai, they are being made with this formwork system. So there are a whole lot of variant table formwork, a whole slab you can make with this kind of formwork system. Okay. Now so this is that customized formwork or engineered formwork. For the timing, you can remember this by aluminum formwork. Okay, and there are different variants, but the most popular variant is this, where the entire enclosure is customized and formwork. That formwork is made and brought to the site, and there are different variations. As I told you, tunnel formwork is not that popular, but as per application, you can use this. Otherwise, if you want to go very high or high-rise structure, then you can use slip formwork or jump formwork systems. So there is another category. Let's move to next category. That is stay-in-place formwork system. So what is formwork? All of you know now. Formwork, once the concrete attains its strength, then formwork is removed. It is no longer the part of the structure, and you do the finishing and all. Another advantage of this is, because we are using aluminum formwork, there is no need to do plaster and all. So you got a perfect smooth finish. Okay, so you eliminate plaster and all also this. Okay, so so formwork is being removed here. If we don't remove that formwork and allow it to be part of a structure, then it is called lost formwork or sacrificial formwork or stay-in-place formwork system. Understood difference? Formwork, first the formwork is used as a formwork to give shape to the concrete, and then that is not removed from the structure. It becomes the integral part of the structure. Okay, so that is why it is called stay-in-place or lost formwork or sacrificial formwork system. And there are two kinds. So once you leave that formwork in the structure or in the building, it will act either as insulation or as a structural part. Okay, so if it acts as an insulation, then it is called insulated concrete formwork system. And if it acts as a part of the structure or it acts as a reinforcement, then it is called structural stay-in-place formwork system. So I will explain you through pictures these two systems. I hope you understand. So ICF it is called, and it is called structural stay-in-place formwork system. And don't try to remember this, but just try to understand the concept. You see this. So instead of this, you have beam, column, and then you have brick wall. Instead of this, we are replacing this by this kind of insulated concrete wall. And this white thing, what you see is, this is called EPS. I will explain you further. Expanded polystyrene core. This is a thermocol of higher density. Okay, thermocol has a density of 1 to 5 kg per meter cube, but this is a just in layman's bracket. But otherwise, its name is expanded polystyrene. Okay, so this expanded polystyrene, through this you make this entire wall. Then what you do the shortcutting, or in between you can fill it with the concrete. So first it acts as a formwork, and later it will act as an insulation, because being thermocol expanded polystyrene, it has excellent insulation property. Okay, and depending upon your height of the structure and all, you can go high rise, you can put the reinforcement, whatever you want to do. Or if you want to have an isolated house, then you can just leave it just like hollow and do the concreting, or you can fill it with any other material. Okay, so and you do the shortcutting. So these again, depending upon your project size and requirements, these blocks are made in the factory, and then through a slide and lock arrangement, they by 1 or 2 persons can construct the entire wall. Okay, and this comes in this form. These are two, it's a block of this kind, and these two blocks are connected together with plastic ties. Okay, so plastic in between you can put stiffeners as well. I have more pictures I'll show you. So replacing cast in situ with factory made formwork system, it is a sacrificial, as I told you, a lost formwork also. You can see this. Okay, and you can see this. So entire house is made with this, and then you can do the concreting. Okay, so because they are left in the structure after concreting, so they act as an insulation. Okay, and its name is ICF, insulating concrete form. And as I showed you, this white thing is nothing but expanded polystyrene, and the width is around 150 mm. And again, as per your requirement, if you want to go high rise, the width can be enhanced to 200 mm or 180 mm, and then these two are connected with a hard plastic ties. And outside you can do shortcreting, or you can simply do the plaster. Okay, yeah, you can see I am using this technology in one of our demonstration housing project. Just so this is the this is a closure look. I am using this technology in one of our demonstration housing projects. So I think you understood this. So these cutouts of doors, windows, you can do either at the factory or at the at the site itself with the cutting tools and all those things, and then you do the plastering. Right now, we have recommended this technology up to G+3, 4 or 4 etc. So there are two companies in our country who are manufacturing this kind of blocks. So you can see any kind of, there is one is Reliable in Supac, I think. So this is the company which are making, if you live nearby Bhopal, you can go and see our project in Bhopal. We have already made G+3 structure there. It is to be used as a training hostel. Okay. Then what you see here, there is another company, and you can see. So again, these are customized. So whatever kind of corners you have, T corners, elbow corners, or any other, these all are made in the factory. And then you put them like this. Okay. And okay, so advantages, as you know, this is lighter in weight, being so better insulation, and being lighter in weight, it provides better seismic resistance. Again, this technology has already been approved by ministry, and we have certified this technology. Also, CPWD has approved this technology. They have also come out. They have also come out with schedule of rate for these technologies. And we have slide and lock arrangement or tongue and groove arrangement. So through slide and lock arrangement, you can build the walls together. Okay, and as per your requirement, if you are in a highly seismic zone or there is a reinforcement requirement, so then in between hollow spaces you can put the reinforcement as well. Okay, so this is called insulating concrete forms. And over this you will do the shortcreting. All of you know shortcreting, or you can simply do the plaster. Shortcreting is with a gun. So you have a graniting gun where you pre-mixture is through a gun you put the shortcreting, and then you put the plaster over it, or you just finish it, so you get an excellent finish. Okay, or otherwise you can simply do the plaster as well when all the services and all are being put together. So again, there will be a detailed lecture on this. So don't worry, I am just giving you a concept. There will be a detailed lecture on this. So instead of brick walls, you can have this kind of thing. Okay, and this is lighter in weight, better seismic resistance. Another variant of this was insulated concrete forms. Then another variant of this is when you have, instead of that, you have this kind of thing. Okay, yeah, you can see. So these are nothing but galvanized MS flats. Okay, so this is a full panel which is made in the factory, and first it is put like this, and then you put the concrete. Here you have a viscous concrete or of low permeability, so which sticks here. So it acts as a formwork, and later it acts as a reinforcement, shear and flexure reinforcement. And these panels, if I have to show you, these panels are composed of two filtering grids comprising of riv meshes. So these are riv meshes which are made of galvanized plain sheet. So galvanized steel plain sheets. With that, these two panels are made, and as I told you, there are two panels which are connected together by vertical stiffeners, and in between you put the reinforcement as well. Okay, again, this technology is being approved by Ministry of Housing and Urban Affairs. It has been certified by us, and also approved by CPWD. Its schedule of rate, very soon the schedule of rate of this will be be coming up, will be coming out by February. So once you erect this formwork in alignment, corners, edges of doors and windows, frames are closed with rebar positioning, and then concrete of required grade is poured in the panels. And once you do the concreting can be done either manually or it can be done through pump bucket system with a shovel loader. And then inside and outside of the walls are being finished with cement plaster. And again, I have used this in 3 demonstration projects of BMTPC, one in Agartala, highly seismic zone. And this being, again, we have recommended this technology only up to G+3 story. So you understood? So these are the ready-made panels which are made of galvanized plain sheet, 2 panels, and they are connected together with a C profile vertical stiffeners and horizontal stiffeners of steel. And then you do the concreting, and all these cutouts are done in the factory itself. So you get these panels, put those panels over the already laid foundation. Again, the catch here for all these technologies that we are coming up to the plinth level and leaving the double bars, and over that we erect these kind of things. Okay, so this may be clear to you here. Like this, they are being put, and then you can make anything. You can make mumpy, you can make a parapet, everything with this, and this acts as a reinforcement later. So that is why it is called a structural state-based compound system. Okay, so there are other variants of this. This is called, again, here, if I have to explain you through which, okay, with this I will explain you. So you can see there is another variant where you have fiber cement board. Okay, so here we had steel, galvanized steel plates. There we have expanded portion. Here we have fiber cement board, and those 2 fiber cement boards are separated by this. You see this black thing? These are nothing but spacers. These are high impact inserts or spacers. So through these spacers, these 2 fiber cement boards are separated, and they can be used either for load bearing applications or non-load bearing applications. So if you are using it for non-load bearing application, then you fill it with lightweight concrete, and if you are using it with load bearing applications, then you fill it with the concrete of appropriate grade. So for structural applications or non-structural applications, for both it can be used. So that is again a lost formwork. So easily available, it can be easily erected over the already laid foundation, and thickness of desired thickness depending upon your requirement. 100, 120 mm, 160 mm, 150 mm, 200 mm, and you can have this. Okay, so there are 2, as I told you, there are 2 variants of this. One is glass wall. Again, all these technologies are patented, or because they are being manufactured by one individual, so they give these technologies their name. So you can say nowadays we are getting brand like we get branded tiles, branded things. Similarly, branded technologies, so they come with their name. So there is a company which makes this. So this is called Plaswall. Plaswall is used for load bearing application, and if you want to use as a partition wall or non bearing, then it's called Plasto light, where it is filled with lightweight foam concrete. Okay, there is another, this I already showed you. This is again a formwork system. Here you have again EPS wall panel. So this is the EPS panel, and then you have a welded wire mesh. I will explain you later also. This is a double wall panel, and again I have used this technology in one of our project in Lucknow in demonstration of it. So again, this is a wall panel which is made in the factory. Okay, and then you erect it, or you can see here, this is the foundation, and double bars, you put this, and then both sides you do plaster, and in between you can put the reinforcement and concrete of appropriate size. Then there is another one. This again, this is very promising, and again there will be a dedicated lecture on this technology. This is called stain-based PVC wall form. So pre-finished wall. Okay, so I'll show you this and this. Yeah, there are 2 slides. Okay, so you can see this is pre-finished. So again, this is a wall form, pre-finished wall form. So means the skin is of PVC. Okay, and this is hollow here. So over the already laid foundation, you get these PVC wall forms. So pre-finished wall form means you don't need to do plaster or anything. These walls are pre-finished, and the color of your choice. You can have it white or white, gray, whatever color you want. You can get it in that color. Okay, so you have these panels which are of, depending upon of your height of your. So again, they are customized. So your the room size is 3 meters, so you will get this panel 3 meter long, and their width is around 3 feet. So 1 meter to 1.2 meter panels, and then again they have slide and lock arrangement. So through that slide and lock arrangement, you can put these panels together to create a wall, and then in between you can put a reinforcement depending upon the size. And suppose this, so again, we have recommended this technology only up to 4-story building. If you want to go high rise, then you have to put steel columns and beams. And again, we are using this technology in one of our lighthouse projects in Lucknow, where thousand plus houses are being made with this technology. Okay, and there are two companies in our country right now who are manufacturing these panels. Okay, so these wall panels are extruded components, come with slide and long arrangements to create a continuous wall. And these two walls are connected together. You can see here with this kind of stiffener. Okay, and in between you can fill it with the concrete. Okay, so there will be a lecture with videos and also. Don't worry, I'm just trying to give you a concept. So this is a pre-finished wall on slide and lock arrangement of required height and of certain width, and in between all wall openings and all you can create, and then you can pour the concrete in between as per your application, concrete of appropriate grade, and you can put the reinforcement, and then you will have these openings and all those things. Okay. This again, this I will skip because again there will be a lecture. This is an Indianized technology. This technology came from Australia initially, but then IIT and BMTBC did a research. So tomorrow, Professor Meher Prasad will give a 1.5 hour lecture on this glass fiber reinforced gypsum rapid wall, GFRG wall panel system. And this glass fiber reinforced gypsum is, phosphogypsum is a byproduct of fertilizer industry. So it's a waste material. So that waste material is being converted into a wall panel, and that wall panel can be used for load bearing applications to paint a building. So there will be a full lecture, so I'm skipping this for the time being. So these are the panels you can see. So these are the other side. Yeah. So this is a full, the panel of this size, which is made, and this is also is hollow. The end is hollow, so it can be easily lifted through a crane, and then this being hollow in between, it can be used as a wall panel and as well as a slab for slab application. So here it is being used as a slab panel. So he will tell you in detail that if you want to use it as a slab panel, then you have to cut grooves and then put the reinforcement. And for wall, you have to put it as it is. And as per your design requirements, every alternate or every third cavity you can fill with reinforced concrete. So you put the reinforced bar, put the reinforcement, and this technology is Indianized again by IIT. Madras, and they will tomorrow there will be a dedicated lecture on this. Now let's move to next category. So I covered two categories right now. One is formwork systems, in which there were two categories. One is aluminum formwork system, and another one is stay in place formwork system or sacrificial formwork. Now let's move to another, which is called sandwich panel system or drywall construction. Okay. Again, I'm trying to give you the concept. There will be a detailed lecture on day 4, Monday, from a scientist from the research laboratory, Central Building Research Institute, who will be talking in detail about this sandwich panel system. Just let me just show you the, explain you the concept. You can see, normally when we talk about wall, what comes to your mind? This is the wall. So you have a wall, 9-inch wall, and 1.5, half brick, or 4.5-inch wall, or full brick wall, the red brick or fly ash brick in English, or Flemish bond. What you do, you would the plaster. So this is the wall. How about replacing this wall by these kind of sandwich panel systems? I will show you what is sandwich panel system or EPS core panel system. EPS core panel system is expanded polystyrene. I showed you, remember, thermocoat of higher density. So this is that EPS, and then you have a welded wire mesh on both sides, and then you do the shotcreting or plaster. So replacing this brick wall by this kind of wall. So the core is a very light material, EPS. So that EPS is sandwiched between two welded wire mesh, and then you do the plaster. That is why it is called sandwich panel system. So sandwich panel system means a softer core or inner core is softer, and which is uh, on both sides you have a sheathing, or a it is sandwiched between two outer whites or outer layers which are of harder material, and that material can be fiber cement board, it can be precast concrete panel, it can be AAC panel, it can be MGO board. So depending upon that outer sheathing or outer board, this is given a name. But the concept is, it is called sandwich panel. So you have an inner core of a softer material, and outside you have either fiber cement board or calcium silicate board or AEC panel, or you can simply have plaster. Okay, so when you have a core of EPS, then it is called EPS core panel system, and other sandwich panel systems are with their names, fiber cement board, MGO board, AEC. And you all might be knowing about is this industrialized building system where we use puff panel. You all know puff panel. Puff panel means you have a PPG, pre-painted galvanized profile sheets on both sides, and in between you have puff. Puff is polyurethane foam. So that is used for industrialized application. You can't use that for mass housing, because so puff in between you. So that core is of puff, and both sides you have galvanized profile sheets. Normally, if you go and see any hangar or any industrial structure, they have tubular structure, and then walls are of puff anyway. So taking proof from that, you can have those entire kind of things, whole kind of things. Instead of profile, you have fiber cement board, and then in between you can have lightweight concrete, or you can have this kind of EPS board. Okay, I will explain you through pictures as well. Okay, so understood the concept. We are replacing this wall or brick wall by whole different kinds of whole lot of kinds of sandwich panel system, which comes with different material, different names, and different varieties depending upon the core and depending upon the outer material. Okay, so core, either it can be EPS, it can be hollow, it can be lightweight concrete, or it can be concrete, or it can be filled with rock wool as well. Okay, and the outer whites or sheathing material, it can be fiber cement board, it can be calcium silicate board, it can be AAC panel, it can be simple plaster or short plating, or it can be precast concrete panel, or it can be AAC panel, Aerocon panel. Okay, you can see here. So you can see we are replacing. So this is the concept, and what we are doing, we are replacing your brick wall by this kind of factory-made, pre-fabricated or precast sandwich panel system. So first I will show you EPS. So this is that EPS panel system I was talking about. There are more than 20 companies in our country who are manufacturing this panel. Again, this technology is suited only up to only up to 4-story structure. So you see, this is that core. Okay, so that is EPS, expanded polystyrene or thermocol of high density, which is sandwiched between two welded wire mesh. These welded wire mesh, galvanized welded wire mesh, and these two welded wire mesh are connected together through stiffeners, jig-jag stiffeners, which give this panel structural integrity. So it's a kind of a space truss, and in between you are putting this softer material. Okay, and it can be single wall, it can be double wall, it can be used as a wall panel, load bearing, non-load bearing, and it can be used as a slab panel. When you want to use it as a slab panel, then then you have to cut a groove and put a reinforcement. Then it can be used also as a staircase. Okay, and you can do a plaster, you can do a short gridding, then you can put a board, whatever. Sky is the limit as per your application, as per your requirement. So there is a whole lot of flexibilities available with all these technologies. Okay, so I think this is well explained to you. So here it is being used for infill walls. Okay, and again this is EPS and all. Again there will be a lecture. So only up to 4-story building. You can see again, as you can see here, up to plinth you have a conventional, and then over this you are putting this welded wire mesh with this. And these panels are made in the factory with welded wire mesh and EPS. You have to just erect them, and they have a slide and lock arrangement kind of thing, and then you do the short cutting from both the sides. You can see here there are other pictures as well, because this is that welded wire mesh I was talking about. So galvanized welded wire mesh, so there is no need of there is no danger of corrosion at all. And this is how it is being done. So this is how it is, short cutting is being done, and then you can do the plaster. You can see all service and all this. It's very simple. This is here, it is being done for floor as well. Okay, this is a finished house. So there are, as I told you, there are more than a dozen companies, and all those companies have been certified by the MTPC, as well as they are being approved by CPWD and the Ministry of Housing and Urban Affairs. Okay, all these official circulars are being made available on your website, on your dashboard, so you can download them and see yourself. So as I told you that there are different companies who are making these panels with their own different names, like we have tiles and all. Similarly, each company have their own name. So there is a company from Italy which is making it with M2, so Emute. So this is the name. Then there is a rapid panel by Wordhouse. Uh, then there is a Jindal Steel is also into these EPS panels. They are making it with the name reinforced EPS 4 panel system. Then there is a quick build by Bird Shell. Then concrete wall is one of the most famous the company Schnell India. Schnell Wireless Systems is a company from Switzerland. Now they have opened an office here. So they make it with concrete wall panel system. So all these are the bow panel system. All these are EPS concrete panel system. Then the Hyderabad industry, all of us know. So Hyderabad industry. So these are EPS core panel system. Then prefabricated system is like this. If you are able to see this, so you have this lightweight concrete here, and then that lightweight concrete is sandwiched between two fiber cement board facing sheets. So this is called sheathing, facing sheets, bites. So these are 6 mm or 8 mm as per your requirement. These are 6 mm fiber cement board, and in between you have lightweight concrete. All of you know about lightweight concrete. Lightweight concrete is a foam concrete or concrete without aggregate. So with lighter weight. So this is only this kind of panel is used for non-load bearing application. So if you want to use it for non-load bearing application, you have to have a structural system, of steel or concrete, whatever you want. Okay, so this is that panel from Hyderabad industry. Then there is another panel you can see here. So here, this facing sheet is of calcium silicate board, and in between they are putting a special concrete called elevated concrete. Elevated concrete is where aggregate is replaced by EPS granule. EPS, I told you, expanded polystyrene. So you have dana or granules of EPS, and then you put cement sand, and that is a lightweight concrete. And that lightweight concrete core is sandwiched between two calcium silicate cores. And these are ready-made panels, again made in the factory, and we are using this technology in Indore project, which I'll show you. Okay, and there are again two companies. One is Rising Japan Infra Private Limited. They are making it with name Rising EPS cement panel. There is another company from Gujarat who is also making this kind of panels. Okay, then there are other companies who are making with different names. There is, so you have a fiber cement board both sides, and in between, you are filling it with another chemical called polyisoprene. It's kind of paper, waste paper. Okay, so this is again used for non-load bearing ball method. So as I told you that you have a, depending upon facing sheets and depending upon the stiffener or inside material, these are being named. So here it is. This is called PIR drywall system. So PIR is nothing but polyisoprene. So it's a kind of it's a very lightweight paper like cardboard kind material. So with that, you have fiber cement board, and those fiber cement board in between you fill it with the this polyisoprene paper board. Then there is a Vishaka industry, very famous for their panels and all. So they are also making this lightweight panels. Again, they have a fiber cement board. So suppose you have this kind of structure, both sides you have fiber cement board, and in between you can fill it with EPS or cement sand, lightweight. So there are a whole lot of things. This is very interesting, which I was telling you that health. So this is a company, again, this is certified by BMTPC. This is called Nano Living. So here, instead of fiber cement board or calcium silicate board, they are using MgO, magnesium oxide board. So this is 2 MgO board, which is used as a facing sheets. Okay, these are 150 mm apart from each other, and in between you put a stiffener. So so inner and outer skin of magnesium oxide with an injected core of lightweight concrete in between. So the core is of lightweight concrete, MgO, and what they are saying, this MgO reacts with the carbon dioxide of the atmosphere, thereby creating healthy environment, and that is why they call it nano living. And this particular system is suitable for up to G+3, 4-story structures. Okay. So go on this side and 15. Okay. Now let's go to next category. So this was about prefabricated or precast sandwich panel system. Okay. Now let's talk about steel. Now nowadays the technology of steel has changed. Nowadays we have hollow sections, built-up sections are available. Let me tell you the difference between built-up and in our times we used to have rolled section. Rolled section means eye girders or angle sections or channel sections. Those are rolled sections of ISI mark. Nowadays you have built-up section where what you do, you have steel plates. The steel plates are welded together to make hollow rectangular hollow sections or square hollow sections or tubular sections or built-up section. Instead of making that rolled eye section, you can make a built-up eye section comprising of 3 steel plates. So because of that, steel has become very effective for mass housing applications. So this is also being promoted, and this is also one of the promising technology. Okay, so steel structure very simple. Instead of RCC frame, what you have, the steel girders or steel beams and columns are cast or produced in the factory. You bring them to the site, just assemble, drywall, no water, nothing is required. Okay, so there will be again a total 1 day devoted on a steel structure section. There are 2 techniques to roll steel. One is hot rolled steel, and another one is cold form steel, where steel coils are rolled through forming machines to give them thin sections. It is galvanized steel. That's called cold form steel. So there will be a 3-hour lecture on light gauge steel. It's one of the very promising technology. Only thing is, it is suitable only up to G+3 G+3 stories, and there will be one full day lecture on light gauge steel. Okay, again, these technologies are being steel. For both these technologies, ports are already available, but with the passage of time, we forgot to use this steel structure. But now again, this coming up, because as I told you, because of the availability of steel sections and with the advancement in the technology of steel, this is being used for mass housing projects as well. And light gauge steel is cold form steel, very promising one, and being used all over the country for quickly erecting houses and other kind of structures. Okay, so I will just show you steel structure system. This is like this. This is like this. You are replacing this thing by this. So these are those built-up sections which are made in the factory, and all you have to do is the already erected, already laid foundation. You bring them and do this, and then these infills can be of anything, whatever I showed you. It can be sandwich panel system. It can be a brick wall. It can be anything you do. Okay, and I'm not going into details. The entire thing can be done. I'll just show you one very interesting slide here. This is the 10-story mall which was erected in 48 hours in Mohali, and that too in 2013 or 14. Okay, 2013, this 10-story building was constructed in 48 hours in Mohali. Mohali is in outskirts of Chandigarh. 2014, and there is no great science. This all steel sections, all these beam and column were concurrently made in the factory, and within 48 hours they were erected, and these walls are of EPS wall. I showed you EPS wall, and there's a company called Insta. So they are promoting this technology with the name called Instant Homes. Okay, so you can see here, these are factory made fast track modular building construction system, patented, and this comes with the name steel. So this technology came into limelight when this building was erected way back in 2013, 10-story, 40-story, in 48 hours. You can see. So these are those columns, and then you can have, there are a lot of flexibility. You can have deck slab. Deck slab is a composite slab where you have a deck sheet, and over that you put a reinforcement, nominal reinforcement, and then you do the concrete, nominal concrete you put. Then this walls can be of anything. In fact, after Hudud cyclone, I was asked to give a technology to rehabilitate the Hudud cyclone victims. So we gave this technology to them. At that time, the rate was very less, and it was done very quickly. Near Visakhapatnam, because there are a whole lot of factories, so they all these columns and beams were made there, and then these are AAC panels, Aerocon panels, and what you see here, these are deck sheets. So these are composite slab. Okay. And again, this is that the puff panel I was telling you for industrial structure. So you have this phasing sheets are galvanized profile sheets, and in between you have puff is a polyurethane foam. Okay. So this is a polyurethane foam which is sandwiched between two layers of metal sheets. Okay. So these are pre-coated galvanized sheet of 0.5 mm thick. And this can be used for infill walls. Okay. Then here you are having puff. Then there are other companies who are using mineral wool. Instead of puff polyurethane foam, you can use mineral wool. So again, these are known as sandwich panel system. So again, you have metal sheets, so same metal sheets, and in between, instead of puff, you are having mineral wool. Okay. So there are other companies. Now let me come to this light gauge steel, cold form steel. Again, as I told you, the professor from IIT Hyderabad will be delivering a great lecture on this. So instead of hot rolling the steel, you have a cold form steel where the steel sheets are put in a former, in a machine former for cold forming machine to produce these kind of thin sections. So thereby the weight of this is less, and this produces a lightweight structure. Okay, and again let me show you. Yeah, so this is that lightweight steel section, and then you put a fiber cement board on both sides, and in between you can fill it with the rock wool. So I'm not going into detail. I just wanted to show you that you can replace this by this kind of thing. Okay, so these are factory made panels, light gauge panels or cold form panels. Okay, very cold form steel, and the production of this kind of panels are different. They are formed through a mechanical process, forming through a machine. So the galvanized steel sheets are put in a cold forming machines with a specific mold to give them shapes, light shapes, and then you produce this panel. And then over the plinth, you put this panels, and then both sides you put a fiber cement board, and in between you fill that hollow space with either with mineral wool or lightweight concrete or a concrete or concrete grade. Okay, so this is how it looks. Then last category is precast concrete construction. Again, we are devoting 2 days because this is one of the most promising technology for high rise, low rise, any kind of structure. There will be specialists from IIT Madras. Then there will be experts from industry as well who will be delivering lectures. Concept is very simple. Now by this time, now you must be now you know that I'm replacing this by this kind of thing. So any shape, facade, wall, column, staircase, chhajja, parapet, mumti, anything you make outside your structure in a casting yard or in a factory, and then put them one over the other. Jointing is also not a problem. You can ask questions about jointing of these from the professor when they deliver lecture. It can be wet jointed, it can be dry jointed, it can be emulative jointing, pakka monolithic joint as you have in the casting steel construction. So there is absolutely no problem. You can see this. Anything, I'll show you this. So any shape you want, all those shapes. This is the pod element I was talking about. So instead of making those 4 walls and all, you make the enclosure and then put already marked place. Okay, staircase, these spandrel beams, all those things can be made. This is one of the projects done by Shirke. Shirke is also like L&T is one of the company dealing with precast concrete construction, and they are making 80,000 houses, 60 to 80,000 houses for DDA in Delhi using this precast concrete construction. So all these panels are made in a casting yard. So they have set up a casting yard at 2 or 3 places in Delhi, and from there they are going everywhere. And this is the factory setup. And I will recommend all of you, if you get a chance, please visit the factory setup of these where they make this, manufacture this or produce this precast elements. Wonderful, all kinds of sophistication. All everything is done with 100% mechanization. They have robots, they have, there is no need to, bind the reinforcement. You just give a command to the computer, and, you have a steel coil, and through that steel coil, through that computer, and through that machine, you will get the your stirrups bent, and you will get your reinforcement, the entire reinforcement cage made through that machine and all. Then you have a, bigger, autoclaving and all, everything pressurized curing, so that you can get that reinforcement concrete elements within 2-3 days, and then they can be transported to the site. So accelerated curing and all, pressurized curing will enable you to make those components faster. Okay. So there is another thing is hollow core panel system. Okay. Hollow core panel system is another variant where you have a pre-stress. So instead of having solid slab, you can have this kind of hollow core. This is also very popular in our factory. So these are, you have a big platform, and these, them, or you extrude the concrete, and then you cut them like you cut the wood. These panels are being cut, and these being hollow, they can be used as a slab as well as a wall panel. Okay, so these are the varieties of precast concrete panel system. In fact, one of the project under Pradhan Mantri Awas Yojana in Naya Raipur was done using this hollow. And you can have various combinations. You can have hollow core wall panels. You can have you can have beam column. Anything you can have. Okay, or you can have beam column precast and then walls of different kinds. So whatever, depending upon the requirement. So one project under Pradhan Mantri Awas Yojana, one of the largest government project was done in Raipur, where we used hollow core. So for slab, we didn't use solid slab, we used hollow core slabs, and for walls, we use that precast large wall panel systems. Okay, so this is that. The next category, that here we were using these kind of planar elements, wall, column, and beams. Instead of this, what about this? If we use the entire house, again, there will be a lecture by the person who executed this project. This is a project done for Tata Housing by Mr. Vijay of Home Mission. He will be, he did this project, and another project he has done in Goa, where they have made these modules near to the site in a casting yard, and then they are putting one over the other to create. So this is called 3D volumetric. You can see any flexibility. You see, this is a pre-finished. Here, this is without the finished. It is pre-finished, and with so this is a topmost module. So you can have a sloping roof. So this entire thing is made in the factory. You can see here. So this is a window or a door, which is again put in the factory itself, and then you can just put one over the other like Lego blocks to create this kind of thing. Okay, and this is just a slide from his presentation. He will explain you anyway. So you have a mold in that you put a reinforcement cage, do the concreting, remove the mold, you get this kind of thing, put it on the trailer, and then we put one over the other. Okay, so that's all about the category. I have few more slides which I would like to show you. The initiatives by Government of India. So as I told you, you were asking about certification. All these technologies which I talked to you, most of these technologies have been certified by BMTBC. And why BMTBC? Because BMTBC is being authorized by Government of India through budget notification to certify these technologies. Okay, so this is the list. And if you want to get more details about these technologies, technical details, their construction manual and all these things, you can go to our website and just look for PACS. PACS is the Performance Appraisal Certification Scheme of BMTBC. And there we have created a detailed certificate. So this certificate is a kind of, pre-standard. So, so you can download that and get entire detail about these systems which I told you. And as I told you that we have divided these technologies into these categories. As I explained, precast concrete, 3D volumetric, precast components assembled at site, light gauge steel structural system, prefabricated sandwich panel system, monolithic concrete construction. Monolithic concrete construction is same, engineered formwork system and stay in place. So 1, 2, 3, 4, 5, 6 categories. Yeah. Here we have clubbed steel and light gauge steel together. Okay. Yeah. So this is the just few more slides for you. Is it visible? Yeah. Now, is it visible on the screen?
Yes, sir. Yes, sir.
Yeah. So now, having said that, having explained you all those technologies and about our initiative, in 2019, what we did, the Honorable Prime Minister desired that we should hold a global housing challenge, and where we should invite all global players who are dealing with global technologies, global construction systems. So what we did, we threw a challenge across the world that please come and participate and give us or tell us about your construction systems which can build or construct maximum number of houses in minimum time and minimum cost. So we threw a challenge to the world, to the technology providers, that do we have construction systems which can help build maximum number of houses, minimum time and minimum cost, and we called it Global Housing Technology. It was a huge success, and please note down this website. All of us, it is given in your dashboard as well. So through this challenge, we shortlisted 54 new technologies. And all these 54 new technologies are categorized into these categories, which I explained you just. So all these categories, 6 categories, we have, we are trying to, explain you in this NAVARITIH course. And please note down this website. This website is very useful. It contains all the information about these technologies, different presentations, different literature, different publications, circulars, and all those things. So anyway, we have given a link. And this challenge was, we organized a, exposition also, exhibition where all the global players exhibited their technologies through their prototype models and all. So that expo and challenge was inaugurated by Honorable Prime Minister in 2019. Okay, and it was a huge success, and we created a basket of 54 technologies. Okay, so these are those 50. If you want to have a list, I will show you the list. That list is also available on your dashboard, and I will be on this website. And these are those 6 categories which I explained you earlier. Stained place formwork system, remember, engineered formwork system, sandwich panel system, light gauge steel and steel structure system, precast 2D and 3. So what these 54 technologies are already approved by Government of India, and we have created a basket. So depending upon your project size, depending upon your financial requirements, time, and all those things, you can choose, and geoclimatic conditions, you can choose any of the technology which suits to your requirement, and construct the house. Okay. So now what we are doing is, these 6 categories. Now, this is not the end. What we did after this, to showcase and to learn more about these technologies, all these 6 categories are being showcased through lighthouse projects, through execution of 1,000+ houses in 6 different states of our country. Okay, so these 6 categories are being showcased at these 6 places, and we are calling them lighthouse projects. Okay, so one is Indore. Indore, we are using, I'll show you pre-current sandwich panel system. Rajkot, this project is already completed, because this challenge was organized in 2019, and in 2020, these projects were awarded, but because of COVID, the work could start only in 2021. So 2021, Honorable Prime Minister laid the formation stone for all these 6 projects, and already now 2 projects have already been completed. Chennai project using precast concrete construction was inaugurated by Honorable Prime Minister on 26th May, and then on 19th October, project in Rajkot is already was inaugurated just a few days back on 19th October, and now next we will be inaugurating Indore, and then Agartala, Ranchi. So here, all these 6 places, these 6 categories are being showcased, different categories. Each project with one category: sandwich panel, formwork system. Here in Rajkot, we are using tunnel formwork. Okay, and we are calling them lighthouse project. Means you can go study these technologies yourself, go stay there, visit these projects, learn yourself. Okay, we are conducting study tours as well. We are also created the capsules, LHP capsules for these the projects. So you can just go to GSTC website and uh, you know play that capsule and learn more about these technologies. The idea is through these projects you learn about these technologies and then implement in your future projects. Okay, so this is called live laboratories. These lighthouse projects are nothing but live laboratories. Live laboratories means you can see, field level, real time application of these technologies. In fact, through this GST website, we have put, web cameras, cameras there. So online, real time execution of these technologies can be seen by visiting their sites through those web cameras. So this is that list. I'm not going into that detail. You can this is available on your website as well. So precast, there are 4 companies. 2D precast, there were 8 companies shortlisted. For light gauge and steel, there are 16 companies. Sandwich panel system, 9 companies. And then for engineered formwork system, 9 companies. The stainless formwork system, 8 companies. And as I told you, 2019 we organized that this challenge. 54 technologies identified. They were categorized to 6 categories, and now 6 lighthouse projects were awarded, and the foundation stone was laid on 1st January 2021. So this is a project in Chennai. You can see here. So we are using precast concrete construction. This project is already completed. And this is the precast concrete construction technologies. Okay, already handed over. And this is that, just to give you detail. So this is the precast concrete construction. This is that, this is the typical setup. This is a casting yard. And in casting yard, you have molds and all those battery molds and other kind of molds. You make those components there. Then those components are transported to the site, and then they are placed like this, and then they do the wet jointing here. This is how this is created. Okay, this project is already handed over, as I told you, on 26th May. It was completed in 12 months, and it has also got a BR rating of 4. Then this is a project at Rajkot where we are using tunnel formwork. Again, this project very recently I was part of this. 19th October, it was handed over by Honorable Prime Minister to the beneficiaries. S+13 tunnel formwork was used. I will show you in next slide. Yeah. So this is the tunnel form. Remember, I was showing you customized formwork system. So this is the tunnel formwork system. So this tunnel formwork is put like this to create these kind of tunnels, and then then casting is done, and then these tunnels are being made, and then the outer walls are of AAC blocks. Okay. AAC blocks are nothing but autoclaved heated concrete, lightweight walls. So the walls which are left, they are infilled with the AAC blocks. Then that Indore, what we are doing is that sandwich panel system. You remember, I showed you that we have a calcium silicate board, and in between we have lightweight concrete. So since it is a high rise, so we are having a steel structure. So skeleton is of steel. These are again a built-up I section for beam, and in between you have this prefabricated sandwich panel system. And this is that roof. If you are able to see, this slab is deck slab. I can show you the process. So first, what you do, you lay the so you lay this, on already laid foundation is conventional raft foundation. Then you have this beam and column built up hot rolled steel sections. Then you put this deck slab I was talking to you. These are profile sheet over which you put the reinforcement. The normal reinforcement. Then you do the concreting along with services, and then you put these panels. Okay, prefabricated sandwich panel system. Then this is a Lucknow. Again, Lucknow, we are using stay in place formwork. That, remember, I told you that PVC wall form. So again, it is a high-rise structure. So structure is of steel, and then the walls are of PVC wall forms. So again, these are factory-made beam columns sections, built-up sections, which are erected like this. Then you put a deck slab. Over that deck slab, you put that pre-finished wall form, and then you do the concrete. And you see this. This is a lightweight concrete is being filled into these PVC wall forms. Okay. Lucknow. Then this is an interesting one. This is here we are using light gauge panel. So you see, Agartala, again, it's a high-rise structure, G+6. So we didn't go for only for the cold form steel. We had a combination of cold form steel and hot rolled steel. I'll show you here. So again, skeleton is of steel. Then these panels are of this light gauge. You can see here, these are light gauge, and both sides, the facing sheets are precast concrete panels, and in between it is filled with lightweight concrete. And this is again a text lab here. Let's see. And all of you, if you are interested, you can go and visit yourself these projects. This is the most advanced technology in our country, where I'll show you next slide, that 3D volumetric construction. You see, this is a picture from live picture. You can see. So these are the pod elements which are made in a casting yard. This is a casting yard where these pod elements are being made, and then they are being put one over the other, create the structure. You can see here. Right now, this is a 9-story structure. Right now, we have reached up to 5-story, 1, 2, 3, 4, 5. So this is that separate block which is put one over the other through tower cranes over an already laid foundation, one over the other to create the entire structure. Okay, see here. So that's all about lighthouse projects. And as I told you, Honorable Prime Minister asked that we all should go visit the lighthouse projects and learn about all these new technologies. So what we have done, we have also launched a scheme called Technography. You are already registered as for NAVARITIH. This Technography is free of cost. You can just visit this GSTC website. Okay. Otherwise, we have given a link on your dashboard also. So you can just go to this website, Technography, this website, and then there is a pull down menu for Technography. You have to just give your Aadhaar details. You have to upload your photo. You will become a Technography. And what we are calling you Technography means in the lines of Swachhagrahi and Satyagrahi. Satyagrahis are freedom fighters, and Swachhagrahis are the change agent for cleanliness. Similarly, Technograhis are the change agents for innovative and sustainable technologies. So you can register free of cost as a Technography, and once you register as Technography, you will get connected to ministry. You will get all the communication from ministry. You can visit these lighthouse projects as and when you require. Again, this is the link. You Technography, you can do it within no time. You have to just put your Aadhaar detail or any identification detail and your photograph upload. So you can take your photograph from mobile and then just upload and become Technography. So for Technography also, we have created a e-module for Technography, where all these 6 lighthouse projects are being explained by me only. So I have created a capsule, so you can get advantage of my lectures on the implementation of those technologies by registering as Technography. And once you finish that module, you are being given a certificate of Technography. Okay, and we are also, so this is one about lighthouse projects. We are not stopping there. We are also doing demonstration. BNTPC is also doing demonstration housing projects. These are the projects which are going, and in each demonstration housing project, we are using a different technology. Okay, so like Guwahati, we are using light gauge. Here we are using Tripur, we are using precast concrete construction. Here we are using EPS panel system. Nagaland, we are using sandwich panel system. Here we are using stain place formwork system. So around 40 houses for demonstration purposes we make in collaboration with the state with the funding of our ministry. So just to showcase this technology and sensitize the professional as well as policymakers about the use of efficacy of these technologies. Also, again, these technologies are being adopted by different states and various departments, whether it is defense, in fact, after COVID, for enhancing medical facilities, this type of construction is being used. If you quickly want to build another floor, these technologies come very handy. And state governments are also, showing keen interest. And you can see this is the list. And as I told you, that all these 54 technologies which are approved by ministry, all these technologies have already been approved by CPWD as well. And for most of these technologies, they have already issued schedule of rates. So with this, I come to the end of this lecture. So this was the introductory lecture. I'm sorry it was a bit longer because I have to take your 2 lectures. So today I have sensitized you about these. What do we have? So we have 54 new construction systems, and these are divided into 6 categories. These 6 categories are amply demonstrated through demonstration housing projects and through lighthouse projects. Okay, and now from tomorrow onwards, the experts will take over and they will, dedicate their lecture on one of the categories. Like tomorrow, we will have formwork systems, then we will have a stain place sandwich panel system, then steel, light gauge, and then precast sandwich panel system. Okay, so with this we end. I will just stop sharing. And let me also tell you that let me stop sharing first. Let me also tell you that tomorrow that there is a change in time. Tomorrow your class will be at 2 o'clock. You can use the same link. Otherwise, my team will send you the fresh link. Or otherwise, you can go to your dashboard. Tomorrow there will be lecture by Dr. K.M. Soni. Will be delivering a lecture on formwork systems, and then followed by a lecture by Professor Meher Prasad of IIT Madras on GFRG. Okay, and don't worry in case you are not able to hear something. Recordings, presentations are being made available to you. This dashboard will also be made available to you. You can go to our YouTube channel or GSTC website and get whole lot of information. In case you are not able, in case you are facing any difficulty, you can always write to us. We will help you out. Okay, and just for the sake of completeness, because there are very few questions, I'll just take fire rating, absolutely no problem. As I told you, in no way we are flouting or we are violating our codes. So if you are having a wall of 160 or 200 if it is used for rating purposes, depending upon it, it requires 1.5 hours rating, so it complies with that. PVC wall forms and other wall forms, they all are, are in line with the codal requirements given in our code. No, we don't have separate codes for all these alternate technologies. Okay, that is why now the schedule of rates is being prepared. Few of these technologies do find mention in National Building Code. See, we don't require dedicated code for these technologies because precast concrete constructions, we already have code for concrete. Okay, sandwich panel system, we don't have code. So for that, code also stipulates that the technology for which you don't have codes, you can follow the international standards. Okay. Okay, I'm sure not by using RMCB. Is it manual or is it in layers? Okay, this question, this we will show you a video. In formwork system, it is being done with kinetic shortcutting and all. So this will be answered, no issues. Okay, this can be done in variety of ways: kinetic shortcutting, loop pumps, and everything. Okay, so with this we come to the end of today's lecture. And in case you have more questions, you can just write to us tomorrow. If time permits, we will take in the morning, otherwise, before the start of the session. And let's meet tomorrow. I hope the lecture was useful for all of you. Thank you very much for being such patient participants. Thank you very much, and good night to everyone.
पंकज जी, आपकी आवाज नहीं आ रही है। हेलो
Sir, where is the dashboard? May I know, sir?
Thank you very much, everyone, for patience hearing. Actually, Mr. Pankaj has stuck somewhere and his voice is not coming clearly. So, thank you very much. Tomorrow we will meet at 2 o'clock. Till then, thank you. Bye.
So where is the dashboard, sir?